So let's today just talk about a parabola. So a parabola can also be defined as the set of all points in a plane that are the same distance from a point called the focus and a line called the directrix. Okay, so the equation of the parabola in standard form. We've seen this before in chapter 6. We called this vertex form when we were in chapter 6 because I can look at this guy and say, hey, I know where the vertex is. He's at h comma k. And x equals h is the axis of symmetry. And then it says if a is greater than 0, k is the minimum value, and it opens up. Remember that? If a is positive. And if a is negative, k is the maximum value, and he opens down. I don't know why that's there. Does that sound familiar? All of that? Yes. Yes. Perfect. Thank you. Okay. Then we have one more bit of information. It says the lattice rectum. Every parabola has a lattice rectum, and it's a line that goes through the focus, and it's perpendicular to the axis of symmetry. Okay, so here we go. See all these guys that are labeled? Let's give them names. Okay, so A, this guy right here. Yeah, he's the axis of symmetry. Remember, if I fold him, my parabola would line up on top of each other. So if I folded it along that line right there, he would go on top of each other. Okay, B, this guy's a new one. This guy right here is called the focus. Think about like a satellite dish. You know that little arm? You got your little satellite dish and then the arm comes out like this. That's your focus. Okay? It's sending all of the information right there. Okay? Focus. C. What do we call C? Vertex. D. D is this line that goes through the focus and it's perpendicular to the axis of symmetry, so that's my lattice rectum. And then E is called my directrix. So, at the beginning up here it said the parabola can be defined as the set of all points in a plane that are the same distance from the focus and the directrix. Meaning, this distance here is the same as this distance here. And that happens, it's hard to tell because I didn't draw it very well, but that's the same the whole way around the parabola. Okay? Like I said, I just threw one in with my calculator or my computer, so that's why he doesn't look like he is. But the distance from the focus to the vertex is the same as from the vertex to the line that's called the directrix. Okay. Turn the page. Questions? Yes, JJ.
So does that mean that if the parabola like moves up,
The directrix will go with it. So will the focus.
okay,
Yes. So if we move the parabola around, those points move with it.
so the farther, like if it's like at like 100,
Uh-huh.
so then the focus will be like 100 away from the vertex, and the vertex will be 100 away from the
Yes.
directrix.
Yeah.
Okay.
Yes. Let me see if I can find mine. Nope. No. I have a little thing we can do, and I can show you that it works. But I can't find my paper. I'll come back to it, okay? Okay, so there at the top of your paper, there in your notes, that is the same thing that's on one side of your formula sheet. Okay? So the information about parabolas is exactly the same as that box. We can have parabolas that open up or down. And we can have parabolas that open to the left or to the right. Okay, same thing on here. Up, down, left, right. Okay, so keep this side of your formula sheet handy. Okay, so number 3 there says, write y equals 3x squared minus 24x plus 50 in standard form. Identify the coordinates of the vertex and the focus, the equation of the axis of symmetry, the directrix, and the direction of opening for the parabola. Find the length of the lattice rectum and then graph it. Holy cow, that sounds like a lot, right? What we're going to do is this formula sheet is going to become your best friend. Okay? So if we can identify A, H, and K, notice we can fill in all of these things. And we're just going to go down the list. Does that make sense? Okay, so it says write it in standard form. Think all the way back to chapter 6. Holy cow, that was like 2 months ago, right? How did we put it into that vertex form? Anybody remember?
We factor it.
We sort of factor. It's our special factor. Completing the square, right? So we're going to complete the square with this guy so that we can put him into the form that we want, so then I can use my formula sheet. Okay, next thing. We started out with like a super hard one too. What about completing the square? Can you have a coefficient in front of the squared term? No. Okay, so here we go. We've got lots of work to do. Let's move our 50 over, right? Y minus 50. And then I gotta trick this guy to not having a coefficient in front of my squared term. Ooh, I forgot to leave room. So I divided a 3 out of both, but I left him out front so that he could be that A value. All right, well, I added 3 times the box on the right-hand side. I have to put it below it because I ran out of room. I forgot to save room. So I added 3 times the box on the left-hand side. Jillian. We could, but we still want that A value out front. So I have that A value there. So I'm just sort of tricking these two so I can factor that. Yeah. Okay, so now I'm going to use 8 and fill in my box. 8 divided by 2.
3.
Square it. So I'm going to put a 16 in my box. Okay, so on the left-hand side, I have y minus 50 plus 3 times 16, 48, equals, remember I'm forcing him to factor. How's he going to factor? X minus 4. Awesome. Okay, so I have y minus 2 is equal to 3 times x minus 4 squared. Move the 2 so the y is by himself. So y equals 3 times x minus 4 squared plus 2. Okay. Are you okay with getting them into standard form? You okay with that? Looks slightly familiar, right?
I have a question.
You bet.
Which standard form do you know how to use, like regularly?
So between these two? Is that what you're saying?
Yeah.
Okay, so this guy, see how he's y equals? So this guy is gonna go up or down.
So like if it starts, if it says y equals,
Yep.
then you do the y equals one?
Yes.
Okay.
See how this one says x equals?
Yeah.
So he's gonna be left or right. So if it depends on what you have here. So since this guy's a y equals, he's gonna be up or down. Great question. Yeah, so we want to use this guy because he's a y equals. Okay, take a quick peek at this guy. See how he's x, y squared? So this guy's going to be a sideways one. Zoe.
So when you're finding like your a, your h, and your x, can you switch the sign on the h?
Yes. Perfect. Okay, so this guy, what's a? 3. Now h, notice that it's x minus h, and he's already got the minus. So I just want that guy to be my h. So if it was a plus, we would take a minus 4, but h is now positive 4. Remember, he's in a parenthesis with a variable. When you take him out, flip his sign. Okay, k. Positive 2. He was plus 2, that's what we've got. So he keeps his sign, he's not with a variable. Okay, so we have our a, our h, and our k. So now we can list things. And what I would suggest is it says find all the things and then graph it. What I would suggest is kind of graph as you go. Okay, so the first thing on my formula sheet says find the vertex. Okay, I got that. H comma k, so 4 comma 2. 1, 2, 3, 4, 1, 2. Okay, moving down my formula sheet, axis of symmetry. I'm going to just abbreviate that AOS. So this guy is x equals h, and we know h is 4, so x equals 4. So there's my axis of symmetry. My focus. He's h, comma, k plus 1 over 4 times a. Well, that looks kind of gross at the moment. Well, that would be 4 comma. 4 times 3 is 12. So 2 plus a 12th. You can leave it as a mixed number. 2 and 1/12. So if I were going to graph this guy, and obviously graphing a 12th gets a little crazy, right? I'm just going to throw them in there. But a 12th, 2 and 1/12 would be inside of my parabola. So he'd be just like right there. It's hard to see, sorry. Well, the distance between my vertex and my focus, remember, is the same as the distance between my vertex and my directrix. So if I went from my vertex and I went up a 12th to get to my focus, I have to go down a 12th to get to my directrix. So I'm going to fill in my formula, or look at my formula sheet. Y equals, my k is 2, minus 1 over 4 times a, which is 3. So that's 2 minus a 12th. 1 and 11/12. Again, you've got your calculator if that's blowing your mind. Obviously, I can't graph a 12th very accurately with these tiny boxes. Okay, direction of opening. It opens up if A is positive. It opens down if A is negative. Which way does this guy open? Up. And finally, the length of the lattice rectum. So I just do LR. So I don't have to write lattice rectum 800 times. My formula sheet says I take the absolute value of 1 over A. Well, my A is 3, so the absolute value of 1 over 3 is 1/3. Okay, now, that is the length from one side of my parabola to the other side of my parabola. Is this guy super fat or super skinny? Skinny. He's only 1/3 of a unit long, right? So what I do is I start at my focus and I go half the distance to the left and half of it to the right. Obviously I can't graph a 6th very well. So as long as you give me a skinny mini, I'm happy. In fact, on these ones, when it's tiny like that, I tend to grade this more than I grade your picture. Now, your picture should match what you're writing right there, though. Okay, so we put it in the right form by completing the square. We find our A, H, and our K, and then we just use our formula sheet and write everything down. Does that make sense? Okay, Jillian. You okay? Okay. Any questions? Clear as mud, right? Okay, let's do number 4. Number 4 is a sideways one. So, we're going to be looking at this column, the very right-hand column of our formula sheet. Okay? If you want to do a fancy fold, you know, so you cover that guy up. You can. There's my fancy accordion fold. Okay. So number 4 says 4x plus y squared equals 4y plus minus 1, excuse me. Identify the coordinates of the vertex, the focus, the equation of the axis of symmetry, the directrix, the direction of opening. Then find the length of the latus rectum so we can graph it. Okay. Notice how this guy is the y squared. Up here we had an x squared, so he was a y equal. This guy, we're going to move that y squared to the other side. So I have x equals negative y squared plus 4y minus 1. Okay? Now, when we complete the square, think about this guy as having a negative 1 out front. So we're going to need to trick it to bring that negative 1 as our a value. Alright, so here I go. I'm going to add move my constant, save room for my box this time since I forgot. Remember, whatever you put in front of your parentheses there has to go in front of your box. So I have negative 1 times my parentheses. I need negative 1 times my box on this side. Okay, let's fill in our box. 4 divided by 2. Square it. 4. Alright, so I have x plus 1 minus 4 is equal to negative 1 times, complete the square. Remember, we're forcing him to factor. Y minus 2, perfect. So I have x, 1 minus 4 is minus 3, equals negative 1, y minus 2 squared. Get the x by itself, negative 1, y minus 2 squared plus 3. Okay, now, look at your formula sheet. What do you notice between ones that open up and down and ones that open to the left or right? The K and the H are flipped. Okay? The A is still there, but now it says Y minus K plus H. Remember that K is your Y coordinate, so he's going to be with the Y. H is your X coordinate, so he's with the X, excuse me. So make sure you notice that H and K flip for a left or a right guy. Okay? So what's A? Negative 1. What's H? Three. What's K? Positive 2. Remember, it was a minus. He's in a parenthesis with a variable, so he's a positive 2. Okay, now I'm going to go down my formula sheet. I've got my A, my H, and my K. My vertex is still H comma K, even though we get those two numbers from different places now. So my vertex is now, we're still 3 comma 2. 1, 2, 3, 1, Henry, yes. So H comes from this guy. So if I look at my formula sheet, H is 3. My K comes from the guy with my Y, so he's 2. But then when we write it, we still write it as H comma K. So think about H as your X coordinate and K as your Y coordinate. Does that help, Henry? Okay, now, think about this as a sideways one. So when we were doing up and down ones, the axis of symmetry would be a vertical line. With a sideways parabola, your axis of symmetry is now a horizontal line. So it's y equals k, or y equals 2. Okay, my focus. Says I'm going to take H, which is 3, plus 1 over 4 times my A, which is -1, comma 2. Well, that would be 3 plus a -1/4, comma 2, or 3 minus a fourth. 2 3/4, comma 2. 1, 2, 3/4. There's my focus. Okay, my directrix says H, X equals H. My H is 3 minus 1 over 4 times a -1. Well, we decided that was -1/4, so 3 minus a -1/4 becomes a +1/4, so 3 1/4. All right, which way does this guy open? If my A value is positive, he opens to the right. If my A value is negative, he opens to the left. Left. And finally, the length of the lattice rectum is the absolute value, because he's a length, right? Think about your ruler, that's why we have the absolute value, of 1 over -1. Well, that's still -1. The absolute value of -1 is 1. So this guy is 1 unit across. Go to your focus. Go half a unit up, half a unit down, so this guy's still skinny. When we get things where a lattice rectum is like 8, he'd be a fatty. Does that make sense? Because he would be 8 units across. Oh, sorry. Thank you. So I started at my little green dot right there. I went half a box up, half a box down. Okay, how do you feel about parabolas at the moment? Who knew they had this much more to them, right? I thought we already did these guys. You okay? Jillian.
Wait, which one is the 9th one?
The directrix is the guy outside of the parabola. He never touches the parabola. So he's the guy that's outside of it. So that in this case, it would be this one that's vertical. In this graph, it's this one that's below it. So he's always outside of it. Okay. Yes, JJ. You bet. The last thing I want to show you, oh sorry, Ashley. The last thing I want to show you is if we go backwards. So what if I give you some information? Could you write me an equation? You can. I have great faith in you. Ash was like, no. You actually can. So I will show you. Okay, so that's really hard to see. Okay, so the back side there says write an equation for the parabola with vertex at 1, 7 and the directrix at y equals 3. Okay, so the first thing we're going to do is graph what we know. Graphing it, what we know tells us which direction it opens, see if we have a vertex, that sort of thing. So the very first thing we're always going to do is graph what you know. Maybe I'll say given. Just like, oh, is that a flashback from geometry or what, right? Okay, so my vertex is at 1, 7. I agree with you. Okay, so this guy right here is my vertex. I'm going to give him a little p. My directrix is at y equals 3. Okay, what kind of lines are y equals numbers? Horizontals, right? Okay, so at y equals 3. 1, 2, 3. Okay, so look at that picture. What do we know? Yeah. Looking at it, now we know it opens up. And if it opens up, then we know it's a y equals an equation, right? It has to open up because it'll never touch this directrix. So this guy, here's my vertex, he looks something like that. I don't know how fat he is, but something like that, right? He's going to open up because I can't ever touch my directrix. Okay, well, because he's a y equals equation, we know y equals, we need to figure out a, x minus, we'll figure out h squared plus k, right? So remember, this is a, h, k. Do we have any of those already? Zoe? We're given the vertex, right? So this guy is h, and this guy is k. So this is 1, and that's 7. Hey, look, we only have to find one more thing. All right, are you okay with that? You see where all those things come from. So looking at the graph, sketching in the graph, we know which way he opens, so we know which equation to grab. Knowing we have our vertex, we have our h and our k already. So we definitely have to have our vertex every time. Okay. Remember the distance we talked about from the vertex to the focus is the same as the vertex to the directrix. So we're going to find the distance from our graph from the vertex to the directrix. So here we go. That's 1, 2, 3, 4. You see that? Okay, now, look back at your formula sheet. This 1 over 4a is what we moved it, right? I went a distance 1 over 4a down to get to my directrix here, and I went a distance of 1 over 4a to get to my focus. Does that look familiar? So what we're going to do to figure out that a value is sort of reverse that guy. So we're going to take that number right there, multiply him by 4, so what's 4 times 4? Put him under 1. That's your a value. You just wrote an equation. It's not bad, right? So we have the h and the k. Questions? Griffin.
So why do you multiply by 4?
It comes from this guy right here. So think about if we were trying to reverse this guy.
So we just don't use the k?
We don't use the k. Because really what this is doing is, this is giving us the distance that we want. So we're undoing this guy.
Isn't the doodad?
Directrix?
No, the other thing.
Focus?
Yeah, that. Isn't that like?
So
So that would be like 4.
he would
above
be
the
4
vertex.
above the vertex. So this guy, if we put him 4 up, he would go 1, 2, 3. There would be our focus if we put him on our graph. So remember that distance is the same for both of those.
So what does the 1/6 do?
That 1/16 tells us, it helps us figure out both of those things there. Okay, so let me show you. With that a value of 1/16, right? If we were going to fill in our formula sheet with this guy, when we do that whole thing, when we do that 1 over 4a, what should we get? 4, right? Because that's what we found him to be up here. So when I do that, ooh, that looks gnarly, right?
Mm-hmm.
So that would be 1 over 4/16. Ew, yowzer.
Which is 1 over
1 over 1/4. Okay, I can't divide fractions like that, so I'm going to multiply by the reciprocal.
Got it.
Is that better? Do you see where it's coming from now? So really the trick is cover up that guy and flip him because it's a 1. But I can't divide those guys, so I multiply by the reciprocal. Any other questions? Want to try another one? Let's do it. Okay, so 6 says write an equation for the parabola with a vertex at 5, -1, and the focus now is at 3, -1. Okay, first thing, same graph what we're given. Graph what you know. So at 5, what?
So we don't need to find the lattice.
You don't have to find the lattice rectum because we found him Because we're just using the graph to sketch what we know. Does that make sense? So we don't have to go through and find everything. You can if you want, but I'm just seeing where my vertex and all that stuff are. Yeah. Good question, Zoe. Okay, so at +5, -1, and I like to put a little V by them or a F by them or something so I know which one I've got. So this guy is my vertex. And my focus is at 3. 1, 2, 3, -1.
That means that it opens left.
Yeah, this guy opens sideways, right? Sketch him in if you want. It doesn't really matter how fat you make him because we're just using our graph so that we know some things. He opens to the left, and since he opens to the left, other than I didn't write the word left, we know he's an x equals. What else do we know? His a has to be negative. Oh, yeah, sorry. Okay, so we know he's an x equals. We know our a is negative. We know he's y minus blank plus blank. And remember, this is a, this is now h, and this is k. Remember, it switched because we're looking at this guy right here. Okay, so what do we know? H and K.
Wait, how did we find H?
He gave us, they gave us our vertex.
Okay. So now
Okay. Distance between the vertex and the focus, or the vertex and the directrix. What's my distance?
we
2.
I did.
Darn it.
I messed up.
2. Multiply it by 4. Put it under 1. So this guy is x equals -1/8. I'm just going to clean them up. Y plus 1, ooh, I forgot the square, squared plus 5. You okay with that? Questions?
Why is the A negative?
Because he opens to the left. So anytime he opens to the left, we know our A has to be negative.
Oh,
Good question. So you sort of have to look at the graph and immediately go, okay, he's negative. Okay, you ready for the last one? Okay, graph what you know. -4, 1, 2, 3, 4, -2. That's my focus. Directrix is at y equals 4. One, 2, 3, 4.
that the vertex has to be in the middle.
The vertex has to be in the middle. They didn't give us the vertex. But remember, the vertex is halfway between the directrix and the focus. Okay? So if this guy is 1, 2, 3, 4, 5, 6, where is my vertex? Halfway, so it would be 3 of them, right? So this vertex point is now at -4, +1. What else do we know? We now know the H and the K, and that this guy opens down, right? Okay, so he's a Y equals, I have a -a, x minus h squared plus k. See if you can do it. Remember, your A is negative because you've got to open down. That's about as tricky as it gets because they didn't give you the vertex. So if you give you the vertex, or no, the directrix and the focus, we've got to find the vertex because we can't write our equation without our vertex. So here's my vertex is at 4, +1. The distance from my vertex to my focus or the vertex to my directrix is 3. 3 times 4 is 12. Put it under 1. So -1/12 x plus 4 now, squared plus 1. Okay, questions? Okay, let's look at your homework and I'll give you the rest of the time to work. So, we talked about 8-1. That one's real fast, so that one's just your midpoint and your distance formula. Okay? 8-2. Some of them are already done and you don't have to complete the square. So I want you to know which ones you need to complete the square on. Okay? Number 1 and number 2, those are both y equals and they're in the nice pretty form. Do you have to complete the square? No. How about number 3? Yes. I'm going to put a box on it so you know you have to complete the square. Okay, number 4. Is it in the form we like? No. Complete the square. Remember there's a 2 out front, so be careful. Number 5. He is now a sideways one. He actually is negative, so he opens to the left. So I'm going to tell you this is your first one that opens sideways. So that one opens to the left. Number 6. That's another sideways one. So your y is positive. This guy opens to the right. You also need to complete the square. So at the moment, you only have to complete the square 3 times. Number 7. Let's rewrite number 7 so you can see him. He has no linear term, so I'm going to take that 1/3, turn him into my a value, and put a 0. So that guy, you don't have to complete the square. Number 8, you need to complete the square on. Number 9, you need to complete the square on. He also is, now you're back to opening up or down, so that guy opens down. 10, 11, 12, and 13. Those ones you're going backwards. I gave you one graph. If you don't really have to graph them, I mean, you could just throw them all on the same graph. If you need more graph paper, let me know, or if you just need a place to sketch it, that's okay too. Okay, questions?
So which ones did you put the left and right on?
Starting at 5, that one opens to the left. So 1 through 4 are up and downs. 5, 6, 7, and 8 are left and right ones.